Hello everyone, my name is Dankaraj Joshi. I am presenting my project on topic Zephyr operating system. This is the real-time operating system based on the Linux Foundation. Let's start with the introduction. Actually, what is the Zephyr operating system? Zephyr is an special types of operating system to work on a device that have a limited computing power and the memory that are like IoTs, fitness tracker devices. This type of devices use the Zephyr RTOS because of the efficiency, occupy the less memory. That's why it's used on this IoT application. So Zephyr is run on the basically, as I told, it's run on the Linux Foundation, and their example are like sensor, LED, wireless. We can control our home lighting system, fitness tracking, like other health medical equipment and other equipment. We can use this operating system. And this is an open source operating system, and there are lots of contributor over available in the GitHub repository. Let's move into the another topics why we choose the Zephyr operating system. So first of all, this is the one of the real-time operating system and open source. So lot of the contributors are contributing on this project. So it is more advanced or more efficient for the ROT due to the is consume the less memory and less processing power. And the safety and security is also the one of the major fact of this operating system. So lots of devices are using this cross architecture compatibility. This operating system is compatible with the lots of operating system like the Windows, Android, Linux based operating system, ARMS processor, different types of architecture is support like 32 bits, 64 bits, and lots of architecture is supports. Licensing. And the another key factor is the Apache 2 licensing. Actually, what is the Apache 2 licensing? Apache 2 licensing is the open source like licensing system on which anybody can modify the existing code and provide these types of license. So because of open source and Apache license to lots of people are modifying according to their needs. So that's why the lots of devices are using the Zephyr operating system. And another point is the modularity and flexibility. This is the more flexible in any device, anywhere we can use it. Another is product ready, include long-term supports from the support teams and the certification ready, and it is a certified product. Let's move into the another topic, supported architecture. As we already told, right, it supports the multiple architecture. Arc for the Arc version 2, Arc version 3, and it support on the ARM version 6, version 7, and version 7 8. Intel it support the Intel 86-bit, 32-bit, and 64-bit. And also the we it supports the multiple RAM processor, MIPS system release 1, NOIS. It support the multiple architecture, so it makes more popular and more easy and more efficient and more secure operating system for the IoTs. Let's, as we told, right there, these are the some companies, some pro architecture. They are using Intel, ARMS, Arc Synopsys, RISC, Tensilic. These are the companies, and these are the architecture where the Zephyr RTOS is used. And let's talk about the core architecture of the Zephyr operating system. The operating system consists of mainly three core parts. First, the bottom part is the kernel, and the middle part is operating system, and the first one is the application system, application service. Let's talk about the kernel. In the kernel, this is the main part and main heart of the operating system. This is based on the Linux Foundation. It consists of the kernel service and scheduler. It support the multi-threading, interrupt services, memory allocation, inter-thread synchronization, lots of things it support. That's why it is more popular. Power management, data passing, and scheduling and configuration. It use the multi-scheduling algorithm, so it's make more efficient, more fast for the small devices. High configuration queue, various type of ready wide variety of like modular design allowed, and different types of configuration this support. Let's move into the, and there are the radios, sensor, crypto, SDO, flash card. These are the device connected, so this support all these things. The second layer is the OS services. OS services consist of different things like it support Device management handle the config. It handle the multiple device system. I2C, SPIC. These are the device driver. It support multiple device driver, file system, low level IP. Then on top of that, it support the low level IP. On top of that, it support the multiple connectivity like Wi-Fi connection, Bluetooth connection, different version, and it manage the device management with the different device driver and threads, and it connectivity. For the connectivity, we can see TCP and UDP also supported here, right? TCP is the transmission control protocol, is the uh, connection with connection protocol. UDP is the connectionless protocol. So, and in top of that, there are TLS, DTLS. TLS means transport layer security. Datagram transport layer security is a DTLS. It is these are the communication protocol. And top of that, there are smart object, high level APIs and data. It support the high level of like APIs. Any APIs can be integrated as per the requirement. It manage the thread management and smart object. Like in top of the application is different type of application it provides. Let's go one by one to the different parts. Like kernel service, as I defined, multi-thread, it support multi-threading, interrupt service, memory allocation, inter-thread synchronization, data passing, power management. So the multi-threading, due to the multi-threading, is the fast processing. Interrupts of it doesn't interrupt any service. Memory allocation is the best here. Memory dynamic management of memory blocks, it automatically manages the block. And another work of the kernel is scheduling and configuration. Multiple scheduling algorithm has been used here, include cooperatives, primitives algorithm, and earliest deadline first. So there is no deadlock process here. It works on the basis on the best scheduling algorithm. Queuing strategy, various reading queue form like linked list, black tree, and traditional multi queues. It support multi, which make the process very fast, data processing fast, highly configurable, modular. So it is highly configurable. Although tailored functionality, multiple functionality, cross architecture support. We already told there are multiple architecture, ARM architecture, Intel, and different CPU. It support different board, different Arduino, on Android's board. Every board is support. Let's move into the second part, that is OS service level. So the OS service level mainly it's device management. It handle the device management, configuration, control hardware devices, different type of hardware device, different types of peripheral devices are connected to this. And with thread management, manage the life cycle and the schedule of multiple thread to ensure efficient execution. Low level APIs are like for I2C, SPI, UART, GPIO, and more direct hardware manipulation. These are the device driver. These handle the multiple device driver like GPU and connectivity. Kernel service scheduling include the mechanism for the task scheduling, resource allocation, and system management. This also be done inside the of OS service level. And the first core architecture, inside the core architecture, application service level. This is the which one is the toppest level. These support the protocol support multiple like for communication, TCP and UDP. We know the TCP is the transmission. This is the this means state level like transmission control, connection based. UDP is the connectionless. Especially TCP are used in the different communication. UDP is where their packet are not important like the connectionless, so it is less reliable. Like it is used in the UTP, like in as example it is used in the video calling system, uh, and gaming system, where the packet sequence of packet does not make has no more value. Like in IPv6, IPv4, it for internet protocol, and LAN, it's for multiple different types of Bluetooth, Wi-Fi, security implementation. Like for the security, like DTLS, TLS for security data transformation. TLS means transmission control protocol, and DTLS is datagram transport layer security. Is communication. These are the communication protocol. So the communication protocol means the communication between the devices is really secure due to the use of these types of protocol. Let's move into the another topics like the product running Jeffries today. As we already mentioned, in different types it use the IoT is different health devices, gym fitness tracking, like we can say ghost gaming, toothbrush in toothbrush. The this operating system is this is the lightweight security and most fast processing. In heroes, smartwatch, gloves, distance. These are the some example. Healthy smart connected iOS. They are using particular sensor over there and sensor to run that to process the data. They are using the Zephyr operating system. These are the some example, few example of where the Zephyr has been used. And let's talk about the advantage and challenges. So the advantage are the minimal resources use. This is the minimal resources use and the small. This is used for the IoT with small resources and small compatible devices. Extensive hardware, so it support multiple hardware architecture from the smart IoT to the of different operating system, different board, different brand, robust security feature. As we already told, there are lots of security, data security, while it transferring from communicating the different protocol has been used, while communicating different protocol has been used like HTTP, UDP, TCP, different protocol, TCP, UDP, TLS, different types of protocol are used for communication, data sharing. So this is the one of the most advantage. Vibrant community and continuous development. As we told, this is the open source project and this is run by the non-profit organization. Lots of developer, lots of computer engineer, software engineer, hardware engineer are contributing to enhance the feature capability and security of this operating system. So that this because of this operating system has a more advantage. And support from major industry player, different as we told, like different giant IT company, different hardware company are supporting this project. Future direction. So for the future, this is not totally pop-up. The company, the group of people, the organization, they are continuously working to make this operating system better. So in future, we can enhance the security feature, better security feature for AI implementation. We can integrate AI capabilities to make it faster, more smarter, more easy, and more reliable. If so, AI is the integration of AI is the most important part because the loss of health or the tracking device run the AI model on that. So it will be, if it will be capable of running the AI on this, it will be really great and improve real-time performance. So the real-time data calculation performance will be need to be improved. Increase speed and security, compact design. We can use these things. Let's conclusion. So Zephyr, as we mentioned everything, Zephyr RTO is a versatile, efficient platform ideal for embedded system with robust security board, hardware compatibility, and strong community support. So there are lots of developer working on this as an open source project. There are AI integration future. We can integrate the future integration. It is the compatible for the IoT. So due to this, the Zephyr is the best operating system for the small or on limited computing power and memory. Thank you. This is all for this project.